In 2013, Traveler 1 achieved an imperative accomplishment by turning into the first human rocket to enter interstellar space, finishing the accomplishment 36 years after the fact. Leaving Earth, the continuous observatory is 14.5 billion miles from Earth, causing messages to expect about 20 hours and 33 minutes to be sent and received. NASA experts didn't guess that Voyager 1 would proceed with space investigation for the greater part of a year. Anyway, the vehicle surpassed expectations, having viewed as 500 dark objects in space. Now, widely acclaimed podcaster Joe Rogan has joined the discussion to share the incredible delayed consequences of this exceptional exposure. What are these clandestine objects? Are they associated with pariahs or a faltering plane? Join us as we research how Traveler 1 distinguished 500 dark items floating in space and observed that Joe Rogan's inconceivable revelations. Have you ever asked why, regardless of the intelligible immensity of the universe, we don't seek substantial confirmation of extraterrestrial human progress? This issue is known as the Fermi paradox, and it has been a secret that has captivated specialists for quite a long time. Anyway, a new experience in the profundities of space has stunned researchers and may reveal insight into the age-old question of whether extraterrestrials exist. Joe Rogan, a trained professional and podcaster known for talking about extraterrestrials and the plausibility of cutting-edge extraterrestrial human advancements, has recently hosted visitors like David Grush and other investigators on the chance of life beyond Earth. Now, new information from Voyager might be the key to addressing whether or not we are truly alone in the universe. Clasp up as Joe Rogan makes sense of why Voyager 1's announcement that it has recognized 500 items crossing space is a game-changer and what it could mean for you, regardless of where you are on the planet. Yet, before we get to the thrilling part, we should comprehend how Pioneer 1's mission came about. Isn't it astonishing to envision that our brilliant world, with its huge oceans and transcending mountains, is simply a little piece of the more prominent universe? Scientists have considered this for a really long time. Anyway, it wasn't long after the 1970s that NASA specialists had the opportunity to determine the size of our galactic neighborhood. Everything started with the surprising arrangement of the 4 largest planets in the planetary group: Jupiter, Saturn, Uranus, and Neptune. In the midst of this divine dance, an alumni understudy named Gary Flandreau, who worked part-time at NASA's Jet Propulsion Laboratory while learning at Caltech, coincidentally found an amazing revelation by cautiously figuring and plotting the orbital paths of the giant planets. Flandreau saw a peculiarity above that would change space investigation. Flandreau's revelations were genuinely notable in the late 1970s and mid-1980s. These 4 planets were followed in a charming example, like pearls on an immense jewelry, with Earth among them. This disclosure produced fervor at NASA since it offered an intriguing opportunity to get to the next-level space travel by using gravitational helps from every planet. A shuttle could push itself forward utilizing a force likened to the draw of undetectable vast strings. Flandreau's trust proposed that gravitational helps from the giant planets could reduce the flight time among Earth and Neptune from an overwhelming 30 years to only 12 years. Anyway, there was a trick. This fantastic game plan happens just once every 175 years. Perceiving the meaning of this extremely rare opportunity, NASA left determined to investigate the planets. 2 shuttles, Adventurer 1 and Adventurer 2, were built with the same plan and mission, launched 15 days apart in the summer of 1977. The twin trailblazers intended to reveal the secrets of the nearby planet group and beyond. Pioneer 1 was sent off on September 5, 1977, and turned into a pivotal piece of the Pioneer program, a demonstration of humankind's interest and journey for information. For almost 50 years, this exceptional space apparatus has continued to travel, sending important information back to Earth through NASA's Deep Space Network. It has turned into our eyes and ears in the endlessness of space, overcoming any issues between our known world and the neglected domain beyond. While wondering at Voyager 1's fantastic journey, it's vital to take note that it is just a breath away from Earth. As of August 2023, the observatory is an amazing 14.5 billion miles from our planet, cautiously planned and built by the brilliant minds at NASA's Jet Propulsion Laboratory and controlled by the Titan III launch vehicle. It began its mission from Launch Complex 41 at Cape Canaveral Air Force Station. When you think you've seen it all, reality unfurls. Now, we should take a deeper dive into this amazing mission of 500 dark objects floating in space and the enrapturing explanation Joe Rogan has recently given on the Joe Rogan Experience podcast. How did Pioneer 1 arrive at interstellar space? Imagine a rocket wandering into the great unknown and exploring the boundlessness of deep space. Soon, that is Voyager 1 for you. This trying rocket is now an extraordinary 14.5 billion miles from our planet. Take a second to consider this distance. It is identical to going around 3.6 times the distance from Earth to the Sun in 1 year. However, there's something else to explore, one than speed, distance, and longevity. It also revealed a significant discovery, including the new finding of 500 dark objects concealed in the immense region of space. This finding is not normal for anything we have seen or explored before. It is a gold mine of massive mystery and wonder, and we are going to reveal the details of this discovery. You might ponder how a rocket launched in 1977 is still functional and providing such exciting information. The response lies in the astounding engineering and vision that went into Traveler 1's design. One of the key secrets to its longevity is the presence of 2 backup computers. Adventurer 1 and its twin, Voyager 2, are equipped with 2 computer subsystems: the Flight Data Subsystem and the Attitude and Articulation Control Subsystem. This overt redundancy is a sharp move that guarantees the stability of systems and the ability to activate computer parts when needed, extending their life expectancy. The computer system on the Pioneer shuttle is designed as a distributed system, including 3 redundant computers. This savvy planning ensures that regardless of whether one of the systems fails, the others can handle the mission flawlessly, preventing essential goals from being compromised. To expand limited power use, Pioneer systems depend on wired logic. Computer systems are designed with intricate algorithms that work within energy budgets and time constraints. Power management during shuttle development was a critical factor in maintaining operational integrity. Voyager 1's distance from the Sun presents a significant challenge to its ability to harness solar energy. To maximize energy efficiency, specialists needed to find inventive ways to enhance energy use. One such strategy involves prioritizing power for essential functions. Engineers carefully analyzed components or subsystems that were non-essential to the mission. For example, the heaters of some scientific instruments were disabled. These heaters were designed to keep the equipment at a specific temperature for effective operation. When switched off, they reduce energy consumption, increasing the overall service life of the space apparatus. Anyway, choices about power management for essential functions are not taken lightly. It involves an extensive evaluation of trade-offs between energy savings and mission goals. Specialists work closely with researchers to ensure that disabling specific systems does not compromise the quality and utility of scientific data. The objective is to find a balance that maximizes energy efficiency while maintaining critical performance. Traveler 1's power management system can adapt to changing circumstances as the space apparatus moves farther from the Sun. As solar energy diminishes, Pioneer 1 adjusts its power consumption accordingly, ensuring adequate resources to support essential tasks and data transmission. It's like having a smart energy saver on board. Over the years, significant technological advances and improvements have been made in power management. Designers continue to refine Pioneer power use through advancements like enhanced power distribution, improved battery charging systems, and refined electrical and thermal management. Because of these effective energy management strategies, Pioneer 1 has surpassed all expectations. Only 6 months after its launch, it continues to provide valuable insights, considering that this spacewalk was first conducted decades ago. Its longevity is truly remarkable. It speaks volumes about the dedication and ingenuity of the scientists and engineers who work tirelessly to maintain Pioneer 1. Anyway, we should not disregard that the depths of space are full of surprises, so stay tuned as more revelations are on the way. Plan to investigate the limitlessness of the nearby planet group and beyond. The Pioneer mission is equipped with a noteworthy array of electronic instruments and systems. These instruments were integrated into the shuttle's fuselage, comprising 65,000 individual parts. Although Traveler began its interstellar journey with a variety of functional gadgets, only 4 remain functional on Voyager 1 and 5 on Voyager 2. One of the long-term instruments on board Pioneer 1 and Pioneer 2 is the Low-Energy Charged Particle Instrument. This gadget features 3 arrays of particle sensors that measure the number and speed of low-energy particles hitting it, identifying cosmic radiation and specifying the sun, planets, and interstellar space. A companion instrument, the Cosmic Ray Instrument, actively seeks high-energy particles from the sun and other cosmic sources. Cosmic radiation instruments now identify materials produced from deep interstellar space and the protective bubble formed by the sun's impact. These readings are significant in determining when Traveler 1 entered interstellar space. It's important to note that the gadget remains functional on both Voyager 1 and Voyager 2, including 2 long radio wires at right angles to one another. The plasma wave subsystem is a critical tool for measuring the electromagnetic field of potentially concealed exoplanets. Anyway, its role advanced as Pioneer entered interstellar space. Today, the gadget provides data on how plasma waves change as they travel through space. Moreover, the magnetometer, originally intended to study the magnetic fields of outer planets, now plays a critical role in investigating the transition zone between the nearby planet group's inner layer and the core. Specialists use this instrument to examine the magnetic properties of the changing region where the sun's magnetic field interacts with magnetic material on the sun's surface, providing insights into how planetary magnetic fields evolve over time. It is critical that the magnetometer remains functional on both Voyager 1 and Voyager 2. Another significant instrument is the plasma experiment, which detects low-energy material in the plasma environment. It can observe objects moving at specific velocities and determine their origin within a predefined range. These resources become increasingly important as the space apparatus adventures further into space. Anyway, it is vital to note that the current measurement only functions on Voyager 2, although some of Pioneer's instruments have been intentionally or unintentionally turned off to conserve energy. The plasma investigation instruments on Pioneer 2 continue to demonstrate significance for scientific research. Moreover, in a bid to conserve energy, NASA introduced heaters on both shuttles in 1998. Each rocket can have up to 3 radioisotope thermoelectric generators, RTGs. These generators utilize the heat generated by the decay of plutonium-238 to produce power. Anyway, as plutonium-238 continues to decay, it can ultimately no longer provide power, leading to the potential end of the whole device. This is expected to occur around 2025. Each Voyager shuttle is equipped with 2 engines, not to move the shuttle forward, but to reposition the receiving antenna so it always points towards Earth. This move is vital to maintaining communication with the shuttle. The engines fire brief bursts or pulses lasting a couple of milliseconds to accurately turn the space apparatus and align its radio antenna towards Earth. In November 2017, due to the degradation of Voyager 1's primary engines, researchers activated the backup engines. This action allowed Voyager 1 to restore contact with Earth after almost 4 years of silence. Astoundingly, the backup engines are capable of changing and positioning the space apparatus antenna, even if it remains dormant for extended periods. The primary transmitter of the Voyager rocket sends around 20 watts of power comparable to the light emitted by a cooler bulb. When the Voyager signal reaches Earth, its power has decreased by 20 billion times compared to a digital watch battery. Regardless of the astounding performance of the Voyager shuttle since its launch, it is worth noting that your iPhone has numerous times more memory than the Voyager rocket. Since you have a better understanding of the Pioneer mission, lock in as we dive into the history of the 500 baffling objects recently found in space. The data sent by Traveler 1 was initially confusing, drawing the attention of mainstream researchers with its most recent discovery. A space apparatus accidentally found 500 dark objects concealed in deep space. This revelation has raised concerns among scientists because these baffling objects remain mysterious. Critically, the initial data sent back to Earth was distorted, likened to a garbled message from afar. Imagine the astonishment on the faces of researchers at NASA's Jet Propulsion Laboratory when they realized they had recovered this confusing data from the most distant reaches of space. Later, through exhaustive examination, the source of confusion was traced to the Attitude and Articulation Control Subsystem, AACS, a critical part of Voyager 1 responsible for measuring, reporting, and correcting the space apparatus trajectory in space. The AACS is equipped with antennas pointed towards Earth to communicate data back to our planet. Researchers recently found that the AACS had been using an incorrect computer, which had been dormant for years, causing disturbances in telemetry data. NASA engineers quickly resolved the issue by reconfiguring the AACS to send accurate data from the correct computer. As a result, Voyager 1's telemetry data is now streaming back to NASA researchers as expected. However, the lingering question is why the AACS was using the incorrect computer. Although NASA researchers can't provide a conclusive answer, they suspect that the AACS received erroneous instructions from another onboard computer. Nonetheless, the specific computer responsible for this anomaly and the nature of the error remain unclear. Suzanne Dodd, project manager for the Voyager interstellar mission, shed light on the AACS situation by stating that a thorough memory dump will be conducted, followed by an in-depth investigation of its operations. This diagnostic process aims to pinpoint the root cause of telemetry issues. Furthermore, NASA's Jet Propulsion Laboratory confirmed that the AACS is now functioning normally and the shuttle remains secure. Thus, Voyager 1 was not forced into test mode, and there was no compromise in signal strength. Although several factors contribute to such errors, one of the most significant challenges is space's harsh environment. The vast expanse is infamous for its extreme conditions, which can present serious hardships for shuttle operations like Voyager 1. The shuttle's instruments are vulnerable to cosmic radiation, temperature changes, material degradation, memory errors, and data corruption. Furthermore, temperatures in space can drop to a bone-chilling -270 degrees Fahrenheit. Moreover, Voyager 1 is exposed to micrometeoroids, dust, and debris from asteroids and comets, which might affect its mission. As the space apparatus adventures deeper into interstellar space, the plasma wave instrument consistently detects the effects of dust particles due to their high speeds of 17 kilometers per second. When a dust particle collides with the shuttle, it quickly deteriorates and ionizes, creating a growing cloud of plasma that produces distinct pulses on the plasma wave subsystem's antenna. In 2013, Voyager 1 achieved a significant milestone by becoming the first human-made object to enter interstellar space, accomplishing this feat 36 years after its launch. As it journeys away from Earth, Voyager 1 is now located an astounding 14.5 billion miles from our planet, with messages taking approximately 20 hours and 33 minutes to travel back and forth. NASA scientists originally did not expect Voyager 1 to last as long as it has. However, it has exceeded expectations, identifying around 500 dark objects in space. Recently, well-known podcaster Joe Rogan has entered the conversation, sharing intriguing insights into these mysterious objects. Are they related to extraterrestrial life or perhaps remnants of ancient spacecraft? This exploration raises questions that tap into the Fermi paradox, which ponders why, given the vastness of the universe, we have yet to find concrete evidence of alien civilizations. This paradox has fascinated researchers for decades, and new findings from Voyager may first shed light on this age-old mystery. Rogan, known for discussing topics surrounding extraterrestrial life and advanced civilizations, has hosted guests like David Grush, who delve into the possibility of life beyond Earth. The information emerging from Voyager could be pivotal in answering the question of whether we are truly alone in the universe. As we delve into this extraordinary mission and the discovery of 500 dark objects, it's essential to reflect on how Voyager 1 reached interstellar space. Launched on September 5, 1977, the spacecraft embarked on a remarkable journey to explore the outer planets and beyond. The mission was made possible by a rare alignment of Jupiter, Saturn, Uranus, and Neptune, which allowed for gravitational assists that significantly reduced travel time. The significance of this alignment was first realized by Gary Flandreau, an undergraduate student at Caltech, who discovered that this configuration would only occur once every 175 years. Recognizing this rare opportunity, NASA set forth on a mission to explore the solar system, leading to the construction of both Voyager 1 and Voyager 2, launched just 15 days apart.